class. We will be starting our science material this week after a slow couple weeks, just learning how to use the platform. I'm really excited to get started with you guys and hope you are ready to learn as well. So, without further ado, let's start talking about the properties of matter. So, I want us to take a quick moment and answer some of these questions. So if you have to, please pause the video and really try to think about these things. So what makes something pure? If I were to say we have purified water, or maybe even pure substance, what does that mean? What does pure mean? Also, how does something become a mixture? We can have lots of different kinds of mixtures, but how do you create one? And what is the smallest unit of matter? So what is everything made of? I'm curious to see what you guys are thinking and hope this can kind of spark some ideas. So we're going to keep going and talk about some important vocabulary. So again, some more questions I want you guys to start thinking about on your own and even trying to write down these answers. So how would you describe the following words? A pure substance, an element, a compound, a mixture, a heterogeneous mixture, and a homogeneous mixture. So understand that you may not know some of these words, and that's okay, but I just want to get you to start thinking about what it might be. And if you can guess, these are the words we're going to be talking about. So here is a really good picture of how everything is organized. We have matter at the top, and then the two main kinds of matter are pure substances and mixtures. And then those both can be broken down farther, so into elements and compounds, and then homogeneous mixtures and heterogeneous mixtures. And we even have some cool pictures of some molecules and to show the differences in each of them. So we'll get into each one. So we'll start with a pure substance. I would love for you guys to write these down in your notes, in your notebook as you watch the video. So the definition of a pure substance is a sample of matter, both definite and constant compositions and distinct chemical properties. So some of these words are kind of big. So a sample of matter with both definite. What does definite mean? I often like to think about a defined amount of material. So maybe 3 oranges is a defined amount. It's definite. Rather than saying, oh, we have a bunch of oranges or a lot of oranges. It's very precise. We have a constant composition. What does that mean? Composition is what makes up the material or the matter. And then if it's constant throughout, that means it's the same. So, for example, if we had a bunch of, let me think. If we had a bunch of water, maybe, they all are the same molecules. There's nothing in the middle of them. And then we also have distinct chemical properties. So a chemical property might be how fast something changes phases. So how fast maybe water boils is a specific chemical property. And those are specific for each substance. That's just what I was saying. Some great examples are water, diamond, and table salt. So please write down those examples. They'll be helpful for further exercises. And then I also am curious if you can think of any more pure substances that might be lying around your house. Alright, so we just did our pure substances, so we are going to go into elements next. So an element is the simplest substance which cannot be broken down by chemical means. It's consisting of atoms which have identical numbers of protons in their atomic nuclei. So our next topic will be learning about atoms and protons and nuclei. So that is some fancy words for now that we will learn later. But the important part is the element is the simplest substance. So it's kind of our base unit, and everything is built on elements. Some great examples are gold, nitrogen, and carbon. And then I'm curious if you guys know some other uses for the element carbon. It is in a lot of material, and I'm curious if you know any of those. Awesome. So we got our element done. We can also see in the element it is the same little blue circle all the way through. So, for example, if this was carbon, here would be a carbon atom, carbon atom, carbon atom, carbon atom. And it's all it's all the same throughout, making it a pure substance. The next one we are going to discuss is a compound. So, a compound is a material that is composed of two or more separate elements. So, some great examples are carbon dioxide, CO2. So, we have our first element being carbon, and then we have oxygen on either side of our carbon, chemically bonded. We also have sodium chloride, which is NaCl. So, the abbreviation for sodium is Na, and the abbreviation for Cl is chloride. This is an L, not an I. And sodium chloride is also known as table salt. So whenever you're putting salt on your food, you are adding sodium chloride. And then I'm curious if you guys know of any other compounds or anything that might come to mind where we have two or more elements bonded together. And yeah, again, another important note is that both elements and compounds are types of pure substances. So going back to our big picture, we can see this little molecule has one element in the middle and two on the side. This very well could be CO2. But we only have this compound throughout our whole substance, making it a pure substance. If we had some other compounds in here, it would look more like a mixture, which is going to be our next word that we're learning. So, a mixture is a material made up of two or more different substances which are physically combined. So, the important part here is there's two or more substances and they're physically combined. So, compounds are chemically combined, whereas mixtures are just physically. Some great examples are oil and water, chocolate chip cookies, which is my favorite example, and salt water. And then my question, just to kind of get you guys thinking again about these words, is how is a mixture of salt water different than a mixture of oil and water? And that's kind of a lead-in into our next words. So that our next one is a homogeneous mixture. So homogeneous mixture is a mixture with a uniform composition. So it has all the same definitions as a mixture, but it's a uniform composition. So homo, for our if we're looking at roots of the English language, homo means the same. So that is in line with uniform, homo. That makes sense. Some great examples are milk, blood, air, and salt water. So if you took a sample from any part of these things, it would look the same regardless. So if I took a sample from the top of the milk carton to the bottom, assuming it's all mixed well, then it would look the same. Also the same with salt water or blood or air. So thinking of our definition, can you think of any other examples of homogeneous mixtures that you have experienced? And another important note, our heterogeneous and homogeneous mixtures are both types of mixtures. I think, yep, just like our compounds and elements are the same, our homogeneous and heterogeneous mixtures are both mixtures. So when we're going back to our homogeneous mixture, we can see in this picture that we have two big circles and then little circles that are chemically bounded. So the difference is, though, they're all the same. So they're all the same in the sense that it looks the same from any point in the sample. We can't see any distinct layers, and yeah, that's the important part. So our next word is heterogeneous mixture, which is a mixture with a uniform composition, a non-uniform composition. So hetero, our root word hetero means different, and so it's non-uniform. So some great examples are oil and water, again, my chocolate chip cookie idea, concrete, and sand and water. So if you've ever had oil in a pan or on a plate and you try to wash it, you can see that it will not want to wash off unless you have soap on it, right? So the water and the oil, if you mix it together, would have two very distinct layers. Also, chocolate chip cookies are a great example because the chocolate chips are not spread out in the same pattern. They might have 2 on one side and 4 or 5 or even 10 in another place. So it is non-uniform. And again, another question, what are some examples of heterogeneous mixtures that you've experienced? And then again, we have our same important note. So I love this example because we can see this clear, distinct layer. We have our two different kinds of molecules, but at the bottom is clearly something different than the top. So it is non-uniform. That is the end of the material I have on properties of matter. I encourage you guys to slow down the video, rewind, listen again, or even pause in the middle to take notes. Hopefully it goes well, and if you have any questions, please let me know.